Okay, good evening, everybody. So let us resume the class for today. Okay, so I will not be going to that slideshow mode. I will be going in this manner because every time, whenever I am changing to the R Studio, this will get paused. Okay, so moving on. I think my screen is visible.
Yes, sir, your screen is visible.
Okay. So now we can how we can add the we can add something in the x axis, that is in the x axis or y axis, or that is the axis. Using what command? That is the axis command. We can add anything to the x axis or y axis. So although most of the high level plotting functions provide some control over the axis construction, typically via the graphical parameters, final control over the individual axis is achieved by constructing each axis separately with the axis function. Okay, just take the code. I will put it in your chat box. One moment, you can all do it. There is some audio is not responding. One moment. So before starting, I guess everybody has changed this your set your working directory. If you have not done it, please do it.
Yes, sir.
Okay. So don't copy this first line. That is just the syntax for your access. Start from the set seed function. So what you are doing this, you are setting the value for the x using the normal function, then you are setting the mean, then standard deviation, then you are making the plot. So I think the plot functions everybody knows. Here one is added, that is the density function. So then you are plotting the x and see what is happening. You are giving the expression. Here expression Na mu, then you have 1 into sigma minus 1 into sigma, 2 into sigma minus 2 into sigma, then position 0 and Cx equal to 2. So in the x-axis you have given the apart from the 0, 1, 2, 3 and 4, you have given directly the one different values. And since this is a density plot, what is density plot? I will tell you this later. It will come today only. I will tell you, but it will come little later. That is why I plotted in this manner. It is a density plot. Okay.
Yes, sir.
Okay. So the density is just a plot. As I told, I will tell you towards the end the various types of plots. Okay. Okay, these are your axis arguments. You have various parameters like site, add, label, stick, line, and so on. The thing is that every day I am giving you this PPT. Kindly keep this very safely, because in the future for our functions and all, this will be very useful. Because anyway you are not using all these functions in all the R codes. So, but in the future you will be definitely using it. So keep this safely with you.
Okay.
Okay. Okay. Next is adding lines and shapes within a plot. How you can do that? There is like one straight lines. Straight lines can be done with the abline function. The low-level plotting abline function is used to fit straight lines within a given intercept A and gradient B, or single values for the horizontal H or vertical V lines. The function can also be passed a fitted linear model, regression, or coefficient vectors from which it extracts the intercept and slope parameters. The definition of the I won't say it is the definition, it is rather it is the syntax for your function. And as I told, this is the this is linear model, and this one coefficient vector, that is all coming for the statistics. And always, as I will tell you, for statistics, for this R data science, it is better you have the working knowledge of this statistics. Some of the statistical methods it will coming will be that I will be teaching in the subsequent classes. Others, it is better whenever you get it, try to see it, what is the function, the parts in your like free time. Okay, accessing the departures from the linearity and homogeneity of variance can be assisted by fitting a linear least square regression line through the data cloud. Okay. So I will be passing you this Christ, this one data set. Please upload in your R. So this particular data set consists of codes, UD, digits, that is a CWD measurements, as well as a number of, this is human impact, land use characteristics for riparian zone. So it is a particular data set. Kindly load it. I think everybody knows how to load it. It is given here. I'm not copying it. I think you can take it on your own. It was given to you. These particular commands are actually very common. And as I told you, you will be using it now, from now onwards. Okay. Just check in your group, the Christ data set is given. You can load it in your, first download it and save it in the folder, which is where you have set your R working directory, and then you can load this data set.
Okay, sir.
See, I have just read the table of Christ, and the contents of this Christ is given here. It is not like Christ. It is the developer name is Christian, so he has given the name as Christ. Okay. So you have a lake area, cabin, dense, and so many other values in this data set. So everybody got it? Yes or no? Are you all able to read the particular data set, and are you all able to see the data set? Everybody?
Yes, sir. Yes.
Yes, sir.
Okay, great. Okay, take this particular code, execute it one by one. So first code is your plot. I think you all are able to see my screen. Yes. So first what it will do, it will plot the x-axis and y-axis with the data, that is CWD dense and RIP dense. Okay, you have your CWD dense here, since this function is given with respect to RIP dense. Okay. Then it is abline function. What is this ln function? It is used to create the linear model, regression model. That is the LM function. You can check it in your Google. Sometimes if you will get some new function, what is the usage? So it has taken the abline function and it has plotted a line with respect to the data sets. Then it will also do the mean of this data set. So here it is the mean. Okay. So abline, first line, it is plotting a straight line because we have given the line, that is straight line abline function. It is plotting the straight line with the values of CWD dense and RIP dense. Okay, with the data of the Christ. Then it is plotting the mean line with respect to this one CWD DNS. Did you all understand it? It's very simple code.
Yes, sir.
Okay. Everybody got it? Anybody who did not get? Anybody who did not get? Okay, let us move on. Then this is lines joining a succession of points, that is the lines function. Okay, the lines function can be used to add lines between the points and is particularly used for adding multiple trends or non-linear trends. That is, in the smoothers you will be seeing it is below. Okay, through a data cloud. As with the points function, the lines function is a generic function whose action depend on the type of the objects passed as the argument. Notably, for simple coordinate vectors, the points and the lines function are virtually interchangeable. Consequently, a more complex example involving predict function. You will get a predict function now. What is a predict function? A function that predicts new values from the fitted models. Again, this predict function is a part of the regression functions. So sorry, regression in statistics. Because in regression, I think everybody knows that you are finding or you are predicting the missing value. Will be used to demonstrate the power of the lines function. Okay, let us go ahead. If you are somewhere you are not getting confused, you are always free to check out with the Google, because as I told, what is this predict function and what is this fitted models, it is all a part of regression. So we can go back and check what is regression in what is done with the regression equations. Okay, and since I am telling you, but if you don't know what it is regression correlation, you are always free to Google the things and you will be getting at least the definitions of how it is done. Okay. Okay, accessing the departure from the linearity and homogeneity of the variance can be assisted by fitting a linear, that is least square regression line, that is the LM function, through the data cloud. So first is leave it. So from this, we'll remove this only. So this is a little bit bigger R code, but do it very execute it line by line. If you are getting stuck in any codes, you can ask me. Though most of the codes it is told. remove this plus signs also, otherwise it will get an error. Okay. So first you can plot, that is the plot function is same like the last. So you have developed the plot. Then divide the data set according to the lake size. So you are cutting it based on small and large.
So this plus sign.
Okay, so if you want to see what has happened, you can just execute this area and check it out. Somebody's Shravani, please unmute. Sorry, please mute. Okay, check this area, what has happened. So you can see the level small and large. So how it has taken it, compare with the data set and check it out. So what it has taken, area, this is the area, and these are all the smalls and these are all the large. All above 100 it has taken as large. Okay, and that it has cut with the, it has used the cut function and it has done in the area. Okay. So what is the next function? It is lm. Lm, I think everybody, as I told you, it is creating the regression plot of the linear regression. So what it is doing it? First execute and check it out. Anyway, will not. So lm small, it has taken the CWD dense with respect to RIP dense with the data set, and for the particular data set it has assigned itself the value small. Okay, it has created a subset of this particular data set, that is CWD dense with respect to RIP dense, and it has created a subset with the name small. And the next, it is for the same, in the same manner with the large, it has created a small data set with respect to DNS, CWD DNS and RIP dense, and it has created the subset with the name large. Next, it has created the lines, and you can see the predict function with respect to the small ln small here. So this is the lm small line it has created. So next it is creating the large data sets containing the large. And now you can see this is a legend function. So legend, what it does? Okay. You can see that it has created the legend here. That is, the title is area and legend is small and large. So I think everybody has can understand this.
Yes, sir.
Anybody can go back and check out what is this LTY function. What is this LTY function? Anybody can tell? Anybody can tell what is this LTI function with respect to lines?
Sir, is this the LTY in about the solid line and dotted lines?
Definitely. Definitely, yes. Very good. So LTY2, it has given this dotted lines here. Okay. And LTY1 by default it has taken the small. Okay. So everybody understood this?
Yes, sir.
Okay. So let us go back. Okay. Lines between the pairs of points, that is the segments. The segment function draws straight line between the points, that is x0, whatever is the values, when each of these coordinates are given as vectors. Multiple lines are drawn, and this is the segments. This is how you are drawing it. That is the function how you are representing this particular function. Assessing departure from linearity and homogeneity of the variance can also be further assisted by adding lines to represent the residual, that is a segment that join observed and predicted response for each predictor. This example also makes use of width function. Here we are getting introduced with one more width function, which evaluates any expression or call. In this case, the segments function in the context of the particular data frame. This is the Christ which is used here or other environment. Let us see the codes for this. Okay. Anyway, the first line is same for all. Okay, so first is the plot function. My screen is shared here. First line, as usual, it is a plot function, it is plotting it. So next is the applying function. Then again we are giving the ln function for the data. Then you are seeing with the width function. So you can see for each and every points it is connecting. Okay. So each and every points it is connecting the line. That is the function of this width function. Width function, yes. And here, as I told, LTY is again here it is 2. If you change it, you will get the solid line or LTY1. Got it, everybody?
Yes, sir.
Okay. Let us move on. Okay, next is the arrows and connectors. The arrow function builds on the segment function to add provision for simple arrowheads. Furthermore, as the length, angle, and end to which the arrowhead applies are all controllable. The arrow function is also particularly used for annotating figures and creating flow diagrams. So see it here. Okay, so start executing. If you are getting an error in this step, please let me know. Are you getting an error?
No, sir.
No. Library execution, you are not getting error?
I got an error, sir.
Yeah, what is the error?
It says there is no package called Gmodels.
Okay, others? Others?
Same.
Same. So you have to install the package. So you have to install the package by name Gmodels. So install this particular package, install packages, and under bracket within quotes it is Gmodels. Please do it. Then this library function will work.
Should
So
we
whenever,
type that above library, sir?
yes.
Okay.
Each library function, whenever you see it, remember it that you have to if an error is coming with this particular library function, it is understood that the package is not there, and you have to insert, you have to check it out what is the package for this. This particular command, whichever I have given you, that is for usually for the grant package. But in the future, that is from the next class onwards, you have to use the bioconductor package. There are usually the bioconductor package is mainly for the bioinformatics.
It's working now, sir.
Yeah, it will work. Everybody, it is working. Before library Gmodel, you have to work with the this one install package. Install packages is the function, install packages. It will take from the CRAN library. CRAN, I know everything. I think you guys know that CRAN is the source for your R. Most data packages are there in the CRAN. Bioinformatics packages are mainly there in the bioconductor. Okay, continue. You may receive an warning message. You can ignore it, because warning messages may come, but if it is not an error, as long as it is not an error, it is okay. So next you are plotting it. You have put the first point with the in the small and second point with the large. Then you can again, it is your width function. So you can see here, if it is width small, the arrow function you can see here from the top to bottom it has come. The arrow head is actually in the middle part. Then the other width function for the large. Okay, everybody got it?
Yes, sir.
So here it is the lower and the upper, the coordinates are given. Coordinate, angle, length, everything is given. Got it, everybody? The
Got
arrow
it, sir.
function. Okay. Everybody got?
Yes, sir.
Okay. Okay, let us move on. Next is rectangle function, RECT. Rect. The rect function draws rectangles from left to bottom, right to top coordinate that can be filled with the solid or stripped patterns according to the line type, width, angle, density, and color. And this is your syntax for your rect function. The main use of rectangle is to produce frames for items within the plots. Okay, take this. So the plot function, as you can see, it has created the density plot with the color gray. Then you are giving the rect function. So you can see the rect function is created with the coordinates as given. Again, the color is gray, border is black. So within the rect, you have given the some codes for which it is that also it is printed in the box.
Sir,
Yes.
I have a doubt. So, if we have to execute the step for rectangle, we have to take the entire code from set till the end.
Definitely, otherwise the colors we have in this particular C, if you are not assigning the colors but default colors it will take.
Okay.
Usually at least these two we have to keep it. Okay.
Okay.
And then it is the color and border color. So if you don't want to assign the color, you can check it out if it is what it is coming, the default.
Okay, sir.
Okay.
Yes, sir.
Okay. Got it, everybody? Okay, let us move on. So Jobita, you can see here for the rect it is like first you are giving the coordinates left, bottom, right, top, density, and then angle. Then afterwards it is the color. That is the syntax.
Yeah, sir.
Without color, if you give it and check it out what it is coming. If you just erase these colors. Are you getting something?
Sir, I have to erase from that call and border also.
Yes.
The default
Yeah.
was black and black.
Yeah, that is what. So what you are getting?
I got black only. The
Black only,
default is
no?
black.
So
Yeah, both
understood
are
that
black.
it is black. So the default is black, but you cannot remove anything apart from this. If you are removing anything else, you will get an error.
Yeah, sir. Yeah. First I got an error. Then I
Hmm.
got entirely black. Like even
Yes.
the code, everything was black.
Yes.
Okay.
So default color is gray and black for the black border. So colors only is the only thing which you, if you want, you can remove it. Rest anything, do not remove. Otherwise, you will get an error because that is the major thing: the rectangle dimensions and density and ANG functions. Okay, let us move on. Okay, next is polygon function. Irregular shapes between a succession of points, that is a polygon. Given a vector of x coordinates and corresponding vector of y coordinates, the polygon function draws irregular shapes. So below is the syntax for a polygon function. As usual, x, y, density, angle, border, and then it is color. Next, as I told initially, it was smoothers. So what is the smoothers? So smoothing functions can be useful additions to the scatter plots. Scatter plots I will come later after this. Scatter plot, particularly for assessing non-linearity and the nature of underlining trends. Smoothers are added to plot by first fitting the smooth function, that is Lowe's smoothing function, and then K smooth to data before plotting the values predicted by this function across the span of data. So check it out, this function, smooth functions. So first one, as usual, it is the plot function. Okay.
Sir, could you post them in the chat box?
Oh, I did not post it. Okay. Done, everybody? Okay, first one, as usual, it is the plot function. Then you are introducing the Lowe's smoother. So check it out what it is doing. It calls the formula in this manner. Whatever is given here, number of observations, it has taken 16, and the number of parameters and the standard error. Okay.
Yes, sir.
Then it has taken this XS function and it has sorted the RIP DNS data. So check it out. What has happened here in the XS. You can see the sorted data. Usually the sorting, as I told in the initial classes, from the ascending order to the descending order. Then the lines. So you have seen the lines. Everybody got it?
Got it, sir.
Okay. Okay, let us move on. Next is this mat lines, confidence eclipses. The mat line function, along with the similar mat plot and mat points function, plot multiple columns of matrix against one another, thereby providing a convenient means to plot predicted trends and confidence intervals in a single statement. Confidence bands are added by using the values written by the predict function as the second argument to the matline function. So check it out, the matline functions. Okay, first one is the plot function. It will plot your graph. Next, you are giving the LM function. You are giving the sig function and giving the maximum to the mean. Then you are giving the matline function. So in the matline, you are given 3 different lines. You can check it out. All the 3 lines are based on the 3 different ranges. Okay, got it everybody?
Got it, sir.
Okay.
Yes, sir. Got it.
Yeah. Now it is the exporting. How you can export the graphics, the pictures, whatever you are getting, the plots. So you can export the pictures either in the PostScript if it is for the Linux and PDF if it is for the Windows. Even in the Linux you can export as PDF, but PostScript function is usually not supported for the Windows. So PostScript is actually a programming language that defines both the. My screen is shared.
Yes, sir.
Yeah. So PostScript is actually a programming language that defines both the nature of the content and exactly how the content should be displayed or printed on the page. As a result, PostScript is defined independent and scalable to any size, and therefore the preferred format of the most of the publishers. Actually, since many people they are using the Linux function, so that is why it is given as PostScript. Otherwise, on the Windows, it is the PDF function. Almost the syntax is the same. While there are many other arguments that can be passed to the PostScript function, common use you can see there: PostScript file, whatever the file you are getting, family, font, width, height, horizontal, and paper. Paper means the paper size. This is the general actually. This is nothing to do with R and all because it's the general format. Whatever the details which is given here. Where a file is a file name and the path, font, and family declare all the fonts required in the device. Width and height define the dimension in inches of the graphics paper, define the size of the printer paper or special for the graphics in which width and height is defined, and the horizontal determine the orientation of the graphics relative to the paper type. So like PostScript, it is PDF, portable document format, which contain information on exactly how the printed pages should appear. PDF documents can also contain great deal of additional information on how the information should behave in different context. So as I told, it is the similar syntax it is for the PostScript and the PDF. Next, you have bitmaps, that is the JPEG and the PNG. How you can extract your the pictures or the graphs which you have generated just now using the JPEG or PNG. R also supports the range of bitmap file formats, the range of which depends on the underlying operating system and the availability of the external applications. So JPEG file name, width, height, units. Okay. Then it is that it should be here. Point size, quality, BG background, RES, and so on. Where file name defines the name of the file, including the path, width, and height, define the dimension of the graphics in pixels. Quality defines the compression quality. 100 indicates no compression. The graphical capability of the bitmap devices are largely tied to the default display device. This one you will be using it when you will be doing the projects and all. So because the directly other usual option, you can take a screenshot. Why you can take a screenshot if you have some commands to extract the files in the PDF or JPEG. Everybody I see, everybody is doing it in the taking screenshot and sending. This is the other way around how you can take the images. Other one is the copy devices. Actually, this is not much concern to you because this is mainly for the Linux. Alternative graphics can be exported to the file by copying the contents of one device, such as display device, to another device such as file device using the def copy function. Okay, next is the high level plotting functions, that is the histogram and others. This one I will not take particularly, you can do it on your own. Histogram, this is the general format, you can do it on your own. I will be sending this particular PPT. Histograms you can do it on your own. So histograms are useful at representations at representing the distribution of the observation for large around more than 30 samples. The number or size of the bins can be controlled by passing respectively a single number or vector of bin breakpoints with the break, that is argument, specifying the probability, that is true arguments will be expressed the number of points in each bin as a density probability rather than as a frequency. So this also you can take it accordingly. So history HIS, this is the file or this is the data set, breaks and probability. Okay, this one I will be sending it to you. You can do it on your own. Then you have density function. You have already seen the density function in the last few plots. You had density. The probability density function are also useful additions or alternatives to histograms as they further assist in describing the patterns of the underlying distribution. A density function can be plotted using the density function as an argument to the high level or overloaded plot function. You can see this is the syntax of your density function. The type of smoothing, kernel, normal or Gaussian by default can be defined by the kernel argument by the degree f smoothing is controlled. Degree smoothing is controlled by the BW, that is the bandwidth argument. Higher the smoothing bandwidth, greater the degree of smoothing. That is the plot density with this is the data set and this is the bandwidth is 1. The density function can also be added to the histogram by the density function as argument to the low level lines, that is in this manner you can do it. Histogram with the lines. Okay, next is the QQ plot. The QQ normal plots can also be useful at diagnosing departure from normality by comparing the data quantiles to each of standard normal distribution. Substantial deviation from the linearity indicates departures from the normality. This is how you can depict the QQ plots. Next, you have the blocks plot. For smaller sample size, histograms and the density functions can be difficult to interpret. Box plot or box and whisker plot provide an alternative means of depicting the location, that is the average, variability and shape of the distribution of data. The dimension of the box plot are defined by the 5 number, that is summary, that is the minimum value, lower quantile, that is Q1, median, that is the quantile 2, upper quantile, that is the quantile 3, and the maximum value representing the 25% of the data. So this is the code for the box plot. The horizontal equal to tree argument is used to produce horizontally aligned boxes. So if you are giving this box plot data horizontal equal to true, then you will get a horizontal box plot. Next, usually I don't think I have hardly come across this rough chart, but it is always you can take it a new type of chart, new type of function. Sorry, this is a new type of chart or plot. Another representation of the data that can be added to the existing plot is the rough chart that displays the values as a series of ticks on the axis. Rough charts can be particularly useful at revealing the artifacts of the box or artifacts in the data that are smooth over by the histogram, box plots and the density functions. So this is your code for the rough chart. Okay, that is done for today. So in the next class I will be taking with like how you can with a particular data set, how you can plot this. Okay, in the meantime everybody take the homework that initially you have created the data set for the responses of your own classmates. You can use all the functions given and plot separately the graphs. Okay, you can load the same data set, that is the response data set of your friends, and plot all the this one R plots. That is the homework. Can you all do this?
Yes, sir.
Did you understand what to do for your homework?
No, sir. Could you repeat, sir?
Yeah, all the R plots, whatever I have taken from the past 3 days, that is from the last
sir.
Sunday till today. All
Okay,
the R plots should be plotted with the data set which I have told you to create by filling the this one response form, the Google form which was sent by Alex. Remember?
Yeah, sir.
Yes, that using the same data set, create this all the R plots.
Okay, sir.
Understood, everybody?
Yes, sir.
Yes, sir.
Chinmay?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Geeta, Priyanka, Rajapriya?
Yes, sir.
Okay.
Yes.
Yes,
Okay. So please inform your friends, Chinmay. Please inform Praniti and Alex. Divya, Yogita, please inform to all your classmates. Rajapriya, please inform your classmates.
Yes, sir. Sure.
So by Thursday, everybody should submit this. And it is not only the data sets, you can change the colors, the font size or anything and see the changes. Not only the data set, because everywhere I have given the data set as are normals are there. So instead of that, use the this one height and the weight. Okay.
Okay, sir.
Okay. So that is a homework. So I want everybody to create the R plots. Then you will understand and change the parameters also. As I told, the font size, the spacings, and how the lines can be represented, everything. Okay.
Got it, sir.
Okay, great. So see you on the Friday again, and I want everybody in the class. I don't know today so many of you are absent. Please please inform everybody that all should be present. I don't know why almost half are only present in the class today.
hello, sir.
Yes, Divya.
Sir, yeah, I have a doubt, sir. Like, I'm confused in one example. Like, you have previously used this loose smoother function. Okay. So, like, I'm thinking that this smoother function is basically used to detect noise. Like, just for example, if we get some data from mass spectrometry, and if we have to detect noise from that, and we have to know what exactly it's happening, at which frequency level the noise is getting, we are getting error from this sample data. So, are we using this looser smoother function in that case?
We can also use that in that case also, because whichever the data set is not symmetrical, you can use this smooth function. Not non-symmetrical data set.
Okay.
Non-symmetrical. I think you know in the statistics what is non-symmetrical.
Yes, sir. Yes, sir.
Yes, because in the lines, all the lines are straight.
Yeah.
Right. So what smooth function does it? Smooth function, it will not create a straight line. It will create across the data. So that is definitely it is a noise, because none of the usually the plots whichever the data set the values are there, it will usually never form a single straight line. So that is what is the your smooth function. It will cover usually, it will usually try to touch all the points.
So it is opposite in LM function, right? By creating
Definitely,
equation
yes,
form.
yes.
Yeah.
Because
Okay.
line function is straight, smooth function is not straight.
Thank you, sir.
Okay, any other doubts? Okay, then if you have no doubts, I will conclude here. And in the next class, we will take the data sets and we will perform some more tasks. And hopefully from the next week onwards, we will start with the biological data. That is a
Okay,
big data. Okay, then. Thank you. Good night. See you all.
thank you, sir.
Thank you, sir.